We're back here in the Grassroots Motorsports shop, but we have a special guest from Classic Motorsports. Hi, Tim.
Hey, nice to meet you.
This is my dad, if you guys haven't put that together. And you brought over a project. What are we doing today?
Well, I've got this steering wheel that we restored for a sports racer that we're building, and I wanted to put a quick release hub on this steering wheel to get in and out of the race car easier and for safety reasons. And the two do not mate up. The bolt pattern, this hub is smaller than the steering wheel, and since this is a vintage wheel and a car I've restored, I didn't want to just start drilling more holes in the steering wheel. So we need to build an adapter out of this chunk of aluminum to mate these two surfaces safely and correctly.
Well, good news. We've got machine tools here.
Yes, we do.
Always up for a fun project.
I knew where to go.
Yeah. So, okay, we're going to take some measurements. We're going to draw the little sandwich adapter we need to make, and then we'll turn it on the lathe, drill some bolts, some bolt holes on the bridge port, and be done.
Let the magic begin.
Going to be a fun day.
Before we get started, we need to thank our sponsor for today's video, CRC Industries. Whenever we have a rusty part or piece of hardware that needs to be cleaned up for a restoration project, we always reach for CRC Evaporus. No grinding or spending hours at the wire wheel or sandblast cabinet. Just place your parts in the reusable solution, and a few hours later they come out rust-free. That's why we always keep some in the shop along with other CRC chemicals like brake clean, parts cleaner, and degreaser. To learn more about CRC and all their products, click the link down in the description.
Okay, so the first thing we're going to do is draw this in CAD. We have a really good CAD primer on grassrootsmotorsports.com that kind of walks through what it is, how to go from pen and paper to drawing in a computer, and what the benefits are. But basically, by drawing this in the computer first, we can avoid wasting, $50 worth of aluminum and just solve problems in the computer and not have to make stuff twice, not waste time, not waste energy. So it's going to take a little bit of time, maybe 10 minutes or so on the front end, but I think we can kind of work through a lot of the issues before we get to actually making parts.
So what's it take for an old guy like me that's scared of computers to buy and use this software?
So there's a bunch of free options. I use Autodesk Fusion, which has a free tier for hobbyists. I have to pay for it because we're doing a commercial activity right now. But it has a free tier. There's OpenCAD, I think it's called. There's SolidWorks. There's a zillion options. I use Autodesk Fusion because it's really well understood and documented by kind of the maker community. It's what a lot of people will already know how to use and what a lot of tutorials will already cover, including the tutorial on grassrootsmotorsports.com that goes into what CAD is and how to use it.
So you're saying help forums and stuff are readily available?
Exactly. And I've never taken a CAD class. You'll probably notice when I violate every single industry norm you can find making this part. But I was able to teach myself how to use it in a weekend with some YouTube videos, basically.
Okay, so if you could use Excel or Word on your computer, you can download this and use it and figure it out in a weekend.
Yeah, and you don't even need people always think you need some fancy computer to do CAD work. You don't anymore. We're running this on the cheapest used Mac Mini I could find on eBay. I mean, it's a $300 computer. So.
And even if you just draw it and don't have the skills or the time to machine it, you can send it out to a place like Send, Cut, Send, and for what, $50 or $100, it'll be back to you in a couple days?
So yeah, the other reason you want to always draw your parts is you might not be able to make what you ultimately need, but it's so much easier to find somebody who can make something if you have a real CAD file or a drawing if it's an old school machinist. Just walking in with kind of a vague idea and, I want this to stick to that, they're going to charge you to design the part. Or if they even have the time and ability and willingness to do it anyway. If you walk in and say, I need one of this file, it's way easier to integrate into a modern machine shop.
So pretty much any machinist would rather have this than something drawn out on a cocktail napkin?
Absolutely.
Okay,
yeah.
Makes sense.
So let's get to work. And,
all right. Ooh.
Okay, first step, we're going to need a circle.
So I measured it out at, I think it's 2 7/8.
Yeah, and that was, you were trying to
so the
measure
idea
the diameter of this?
Yeah, they were trying to hide it behind the steering wheel, but have it big enough
Gotcha.
that
So
you got
we'll
good
actually,
threads.
we can test this pretty easily. I'll show you. Okay, so we've got our circle here, and we'll go ahead and extrude that into a solid body. And we'll just say it's an inch thick for now. That'll probably change, but it's an easy way to do it.
I'd like it thinner, but we'll see.
We'll get to that.
I got you.
So next, I'm going to go ahead and draw the steering wheel bolt pattern. I'll make another sketch on the top face. I went ahead and sized the hole to the tap drill size we're going to need. And then I created a 3-hole pattern. Now that's the steering wheel pattern we need here. Now, but we don't have the distance between these holes set yet. So I can go ahead and measure that quick. This doesn't have to be real exact, and I'm betting it's a square or a round number. Yeah, I'm almost positive that is a 2-inch pattern. Of course it's different in every hole. Yeah, we're gonna call that 2 inches just to start. So to dimension that, you just set the distance between these 2 holes at 2 inches, and then that will fix the whole pattern. By doing this way, if we need to change that later, it's really easy to do. Just do that, and it also keeps everything square and happy and all that. Oop, 20 is not 2, it should be 2.
So that was my problem, is the holes are very far out to the edge of the disc.
Right, so we're gonna go ahead and extrude these down to turn them into actual drilled holes. A negative ½ inch just to start. Actually, is that enough? I forgot we already have the screws. So these are ½ inch screws, which means ½ inch a hole plus the steering wheel. It'll probably be barely enough. I'm gonna add just a little more to give us clearance for that tap drill we're gonna need, if we don't end up just drilling them all the way through. Okay.
Yeah, I'd like to keep the actual disc is hopefully ½ inch or less.
Yeah. So before we go any further, we're going to go ahead and print this out on a piece of paper and actually do a test fit to make sure we like what we're drawing here. So good news is our pattern seems to be pretty much spot on. And the steering wheel holes aren't perfectly centered. But so as you can see, it's going to be hidden behind the wheel, but only barely. You can still kind of just barely see that outline there. So we might want to make it a little smaller if we can get away with that.
I was just worried that your holes would get too close to the edge and not be safe. But I guess your torque is not out, it's sideways.
I think
when you turn a steering wheel.
And it's definitely, you're going to see this. You'll definitely see it along the bottom here, I think. Actually, just barely getting away with that. You want to keep this dimension?
Well, the cool thing is, if you get it all done and it doesn't look right, how hard is it to machine it down an extra couple thousandths or whatever?
Kind of a pain in the butt, but not the end of the world.
Yeah.
Okay, so we're going to call the steering wheel side of this done, which means we need to go onto the bottom side.
So what we'll have to deal with is putting the steering wheel onto this is simple. So we'll just thread this, use these bolts, and be able to bolt that right to there. Easy. But how do we take this and then get it onto here? And the answer is we'll have to countersink this to whatever depth we make this, hopefully about ½ inch thick. We'll have to countersink this to put these in, because whatever bolts we use to put this to this cannot protrude up into here, so they'll have to be countersunk.
Okay, so now I'm on McMaster Carr because we need to plan to leave room for our screw head, because we need to fit a head under here before we put the steering wheel on. So I'll get some flathead screws. Looks like we've got about 800 thou, just over, of depth that they've tapped this hub to. So if we have 3/4 inch long bolts, that's plenty. Okay, the file is complete. Now we just need to update our drawing and then actually make it. So we'll do that next. We have to turn this piece of stock into something appropriately sized for our parts. We're starting with a way too thick and way too big a diameter piece of aluminum. So it's going to be pretty boring for the next few minutes as I just turn it down into the rough piece of stock we need. Now, if we were buying stock, we would just order something that was way closer to size, but this is something we had lying around. Might as well use up scraps. I'm going to take like an inch off of this and like an inch of diameter too. Jeez, yeah, it's going to be a little bit of a haul here. Nothing we're doing, especially in aluminum, is that hard to do on a smaller machine. And this is not a big lathe by any means. It'll just take longer. So if you don't have a sturdy lathe with a big motor like this, just plan on spending a little more time on each cut. You can still totally do it as long as it fits in the chuck, but this isn't that big.
You might be wondering why I bothered drawing this part on the computer if I'm just going to make it with manual machines. I'll always draw my parts before I make them. Then I go ahead and turn that CAD into dimension drawings, which are referenced throughout the machining process instead of trying to memorize every measurement. This is just an easier, faster, more accurate way to make stuff.
So I'm not a lathe tooling expert. I'm not going to pretend to be. I use carbide tooling exclusively because I hate grinding my own and hate getting into that. You'll see me swapping around tooling a little bit just to hit different angles. Some tools are better at a lot of material removal and heavy cuts. Some like this little round insert tool leave a really nice surface finish. There's a million better YouTube videos that will go really deep in the nitty gritty on what tools to use when. But just know that this isn't thousands of dollars of tooling either. A couple $100 for everything you see and use, and it lasts forever in the home shop. So we've got our little chunk of metal. Came from our big chunk of metal. I need to do 1 or 2 more passes just to clean up the face and get it to our final dimension, and then it'll be time to drill our bolt pattern. So we've got 6 holes to drill, and to do that, we'll go over to our other Facebook Marketplace find, the Bridgeport mill. Now, this is way overkill for drilling 6 holes in a piece of aluminum. To say
I got a portable drill.
I'm going to use this because I already own it, and it's right next to the lathe, and it's going to make a really precise, nice part. But if you don't have your own Bridgeport mill, go buy one. No, if you don't have your own Bridgeport, you could do this with a drill press and with one of those paper templates from the CAD like we used before. It's super easy to lay the paper template out on your part, use a center punch to mark the hole locations, and then drill it with a normal drill or a drill press. But when in Rome, do as the Romans do. Voila, we have an Elva steering wheel on a modern quick release hub with this little adapter. There you go. Oh. Have fun.
Yeah, it looks beautiful. And obviously you're never even going to see that behind, the wheels right up against the dash. So you're not even going to even see that. So another major step, or at least minor step, completed on this long-term sports racer project we've been trying to restore.
So I know what you might be thinking. I don't want to spend $5,000 on machine tools and a couple hours of my own time trying to make this part. Is there any other way you could possibly make a custom steering wheel adapter? Yeah, if you draw this in a free CAD program and upload it to a company like SendCutSend, you could replicate this for $27 and a couple days of waiting for shipping. So we never claimed to be smart, but we did make our own hub in the garage.
But you give a guy a fish, you feed him for a day, you buy a Bridgeport and a lathe, you feed him forever, right?
Sure, yeah, whatever makes you feel better.
I mean, how many projects have you made with those tools?
Fair enough.
You've saved thousands in machining costs, and there's time. You know, you take this to some place, and they're going to say, okay, I need 2-3 weeks to do it. So as you can see, we need to get on track with this thing in the next week.
Yeah.
So if you like this sort of stuff, please like, subscribe to our channel, and check out our website, classicmotorsports.com, where you can read about this crazy project and all the other stuff we're doing.
Support brands that support Classic Motorsports. Get your chemical solutions from CRC Industries. Visit crcindustries.com to learn more. If you like this video and want to see more, make sure to hit that subscribe button and like this video. And to see more stories like this, visit us online at classicmotorsports.com.